Hello everyone, this is Josh and Manny from Shotgun Software, and we're here to talk about cloud-based pipeline distribution. For this talk, we collaborated with Rudy and Satish from Perl Studio. Unfortunately, couldn't join us for this presentation, but we'll do our best to tell you their story, and I encourage you also to read their paper if you need more details to find out about what they're doing. And then, of course, if you want to get in contact with them, just let us know via email, and we can put you in touch with them. Before we get started, if you're not familiar with Shotgun, here are a couple of really quick screens to give you an idea of what it is. Shotgun is a web-based production tracking system. Producers, supervisors can input the content the way they want to track it, build schedules, assign people to do the work. Shotgun is also a web-based review platform where artists can submit media, get it reviewed, and iterate on it. For this talk, we'll be focusing on how Shotgun integrates with the software artists use. These integrations are built on the Shotgun Pipeline Toolkit platform. From an end-user perspective, Toolkit is represented by a series of apps that artists use to manage their work. Under the hood, these apps are updating Shotgun with information to track the artist's iterations. Toolkit apps are often reused in multiple content creation applications. For example, you can use the same publish and loader apps you saw in Maya on the previous screens in Nuke, as you see here. So that's a really quick summary of Shotgun and Toolkit. If you're curious to learn more, please check out our DigiPro talk from last year. The motivation for this talk is to look at how Shotgun Toolkit has been evolving to support more distributed workflows. In the classic studio setup, a collection of artists sit in a single location using a shared network storage to house their workflow tools. This setup remains common today, but in recent years we've started to see our clients become more and more geographically distributed. These connected locations can be different offices within the same studio, different vendors sharing shots, and clients working with vendor studios, or even remote artists working from home. Before we go any further, I want to be clear what we're talking about. So a little bit of a disclaimer. We're talking about tool distribution, not file distribution. In other words, how do we get artists the pipeline tools they need and the workflows defined by these interconnected tools? So implementation-wise, what's new? Toolkit now enables a just-in-time pipeline distribution mechanism via Shotgun. In this section, we'll take a quick look at what this really means and how we got there. To paint the full picture, it's important to understand the concept of a toolkit configuration. A configuration is a description of a pipeline. On a fundamental level, it describes the apps an artist use within the content creation packages like Maya, Nuke, or Houdini. Settings for each of these apps define the artist's workflows within a given production context, like asset builds, for example. Other contexts might include sequences and shot workflows. All of these together make up a toolkit configuration. The config gives the pipeline TD a single place to control what workflow tools artists see on production. One of the fundamental things to know is that the apps referenced in the configuration are just pointers to the actual code. The source for the apps might actually live in the Toolkit App Store, in a Git repo, perhaps in GitHub, or locally maintained codebase on a Studio Network file system. Each reference is typically to a version of the app under source control. There's a lot more under the hood here, but in general, the toolkit configuration is a very lightweight description of a pipeline. To ground this a little bit more and give you a peek under the hood, here are just a couple of YAML snippets from our default toolkit configuration. On the left, you can see some toolkit apps being referenced from the Toolkit App Store. Note the version numbers. On the right, you can see the sequence and shot configurations for Maya and references to some of the apps that the artist will see. In the past, a studio using Toolkit would need a pipeline TD to curate and manage the configuration locally. When the pipeline TD or admin installed the configuration on the network file storage, all the required tools would be downloaded based on their referenced location in the configuration, and then be made available to all artists in that location. While this works well for a single location, the addition of other physical studio locations creates a management problem when it comes to configuration. As you saw in the previous slides, Toolkit supports several locations where apps can be referenced. So we wondered, why can't an entire configuration be referenced from somewhere? Further, if artists have to log in and authenticate with Shotgun anyways, why can't the configs themselves just be stored in Shotgun? So we added a Studio Shotgun site as a valid payload location. It's now possible to store an entire pipeline configuration in Shotgun, so effectively, if you have access to your Shotgun site, you have access to your pipeline. What does this look like in practice? As artists launch their content creation software, a lookup is performed in Shotgun to find the appropriate configuration. Once the correct config is identified, based on the user and project being worked on, it is downloaded to the artist's machine. From now on, whenever the uploaded config changes, artists will receive those updates automatically when they launch their software. This results in a just-in-time pipeline that can be curated and distributed from anywhere and used by artists in any location as long as they have access to a Shotgun site. In this section, we'll look at the case study of Perl Studio and their adoption of workflow distribution via Toolkit. If you're unfamiliar with Perl, they make animated family-friendly entertainment for the global market. They were previously known as Oriental DreamWorks, but underwent a rebranding. They also co-produced Kung Fu Panda 3. Let's first take a look at their history as far as their pipeline goes. Perl Studio began using Shotgun Toolkit. They've been using Shotgun Toolkit for a while, as far back as 2013. It was a simple toolkit-based pipeline for VFX and animation projects for the Chinese market. While working in collaboration with DreamWorks, they were using a feature animation microservices-based pipeline. They were integrating with DreamWorks and working with their existing tech stack. In 2017, the partnership with DreamWorks ended and Perl felt like they had an opportunity to rework and rebuild their pipeline from the ground up. So they moved back to Toolkit in a single site, centralized Shotgun-based pipeline. Here's a map to give you an idea of how Perl Studio is distributed. They have their creative hub in LA, a development office in Shanghai, another office in New York, and they outsource work to vendor studios in places like Vancouver, Montreal, and LA. As the studio became more distributed, it was pretty clear that the classic centralized Toolkit setup wasn't going to work. So the team began doing research into what was out there and listing requirements for their ideal pipeline. Their primary needs included the ability to support workers from multiple locations around the world who may not have access to VPN. Their pipeline had to work with little or no tech support from a deployment perspective. The pipeline needed to automatically update itself on launch, pushing tools to artists as needed. Individual components of the pipeline needed to be able to be updated independently. The ability to define a studio-level workflow and override pieces of it for individual projects, sequences, shots, etc. was also a requirement. They began diving into what was out there, including the recent changes to Toolkit. What follows is an overview of the solution they've been pursuing for the past year and how it meets these requirements. With the ability to upload a config to Shotgun, Perl can upload variants of their configuration. These include development, staging, and production variants. Artists and developers can then start up their content creation software and the proper config will be pulled down to the artist's machine. And it doesn't actually matter where the artist is located. It could be Canada, China, or some artist working from home. What this means is pipeline deployment is simply a matter of creating a zip file and uploading it to Shotgun. The ability to distribute configurations checked off the first box of their initial requirement. From the user's perspective, the experience is the same as it has always been with Toolkit. They simply start Shotgun Desktop, click their project, and then click the content creation software they want to launch. And then the application starts up. They have access to the tools that have been configured for them. There's no need to have a pipeline TD in the artist location, at least in terms of getting the pipeline there. This meets Perl's second goal of having minimal tech support in the artist location. Now we'll look at the development process Perl has adopted with respect to uploaded configs. A typical feature or fix request comes in from production. When the request is received and development is ready to begin, the developer clones the production configuration source. If, for example, they're making a fix to one of their custom apps, they'll also clone that app's repo. Then they'll branch the code and change the dev configuration to point to the newly cloned app on that branch. At this point, the developer iterates on the app and tests their changes locally. Once the app is in a working state, the staging configuration is updated to reference the modified app, and any changes made to the configuration itself during development are also merged in. The new staging configuration is then uploaded to Shotgun. The developer can then grant access to the staging config to the artist who had submitted the original request in Shotgun. That artist can then use the config to test the changes without affecting anyone else on production. Finally, when ready to release, the production configuration is updated with the changes. A build process runs that bundles the updated app into the config's cache. The new production configuration is then uploaded to Shotgun. The next time the artists launch their content creation software, they'll get the updated app. This is Pro's development cycle. In terms of the initial requirement, this process addresses the ability to push updates, and it also allows individual components to be updated. Remember, we're uploading an entire configuration, but because it's a collection of references, only the modified app will be updated and cached on the artist's machine. As mentioned, configurations can be project specific. When a user working on Project A starts their content creation software, Toolkit will look for a Project A configuration in Shotgun. It checks each configuration known to Shotgun. If one doesn't exist, the studio configuration is pulled down for the artist. If a user working on Project B does the same, and a Project B configuration is found, it will use that one. This partially satisfies the requirement of config level overrides. It is possible to restrict at the user level as well, which is how the developer configs are managed, but Perl is looking for additional deeper levels of override that aren't currently possible. This is something we're considering on our end. So that's how Perl is utilizing recent Toolkit changes to distribute workflow to their collaborators both internally and externally. Their pipeline is still a work in progress, and we're excited to work with them and our clients who are using other clients who are using this technology. I encourage you to read through the paper if you're interested in learning more about what Perl is doing to find additional details about the lessons learned during their pipeline building journey. With all that, I'll hand it over to Manny to look at common workflow distribution patterns.
Hi guys. We are now going to dive into the more general patterns section of the talk. So over the past year, we've been working with a number of different companies who've started to leverage Shotgun to distribute pipelines to their users, remote as well as local. It's been exciting to watch this space as our clients have started to experiment with the ability to upload configs into the cloud. So here are 6 common patterns that we've seen or helped build in the last 12 months. These 6 patterns are all about solving variations of the same problem, allowing a pipeline TD to curate a Shotgun Toolkit configuration, zip it up and upload it to Shotgun for distribution to users. This simple workflow allows for rapid iteration and deployment, and all that artist needs to do on their end is to start their application, log into Shotgun, and they will receive the latest pipeline tools automatically. The first pattern is based around running a central launcher application where the artist can go to find all their tools. The more generic pattern looks like this. The artist launches a desktop application and logs in. At startup, the desktop application automatically downloads the latest configuration version from the cloud. The configuration is analyzed, and any dependencies that aren't already cached locally are downloaded. Via the desktop application, applications such as Maya and Nuke can be launched, and the pipeline tools will automatically appear after startup. Practically speaking, here's what happens when an artist is using the desktop application we provide, Shotgun Desktop. So you start by logging into your Shotgun site. You then see a list of all your Shotgun projects. You click on a project. At this point, the Toolkit configuration and apps are downloaded and cached. You then see a curated list of applications and apps that you can launch. You click to launch, for example, Maya. And when Maya starts, all the Shotgun Toolkit apps will be available. Now, for our second pattern, sometimes a large pipeline covering multiple applications is not needed. Perhaps you have a workflow that only involves one particular application, or you only want to deploy a single useful tool, for example, a Toolkit app that helps compositors really quickly upload their renders for review. This second pattern shows you how you can embed a Toolkit config into a plugin so that you can inject tools directly into the applications that artists use. So most artist applications, for example Maya, Nuke or Houdini, support some form of plugin concept. A lightweight plugin can be authored and be distributed to users. And when the plugin initializes, it authenticates the user and downloads the latest configuration. Dependencies that don't already exist locally are then downloaded, and the tools defined in the configuration are now available to the user. So in the case of Shotgun and Maya, here's what it would look like practically. A simple Python plugin is written and distributed to all artists. Using Maya's plugin manager, you would initialize the plugin. If you haven't logged in before, you get prompted to log into your Shotgun site. The plugin starts up, and you then have access to Toolkit apps. And this example shows Maya. However, the Toolkit platform supports a number of other applications that can be extended to add more. So the third pattern coordinates tool chains across different companies and can, for example, be used to distribute tools for ingest and delivery workflows. 2 VFX Studio vendors are working on content for a client. They all have separate Shotgun sites. The client wants to send out and expects to receive content from studios in a certain format. One way to achieve this is to provide the vendors with delivery tools that help ensure that data is sent back, that the data that's sent back has the right file naming, burn-in, slates, color space, etc. The client creates 2 configs that are meant to be deployed as a pair. The config is distributed to all vendor sites and to the client site. You can keep everyone in sync simply by uploading zipped up configurations to all sites. Deploying to a large number of sites is easy and can be automated into a build, staging, and release process. These tools can live side by side with each studio's own existing pipeline. Now, vendor users can, for example, use the desktop application pattern to log into Shotgun, then receive the tools that they need to send content back to the client site. And the client has a similar setup for receiving the content from the vendor toolchain. So far, we've discussed artist-facing tools, but the same principles apply for compute and render farms. If you want to push custom scripts or workflow logic to a render farm job, you can do that too. Toolkit has a Python API that lets you control the configuration loading. At compute time, the configuration required for a given job can automatically be retrieved from Shotgun. For example, a render farm Python script uses the API, which will connect to Shotgun, retrieve the config and its dependencies. Tools or automation can then be executed. There are also several variations around how configs and their dependencies can be cached and retrieved. Our 6th and final pattern is about baking your configuration into a self-contained setup. So not all studios allow artist machines to access the internet. Usually this is related to security restrictions. So how do we prepare a configuration for this case? In this situation, it's possible to distribute a self-contained configuration with no external dependencies. Instead, all apps are downloaded into a folder in the configuration. This is the pattern that Pearl Studio ended up with for their pipeline setup. In this case, you begin with a configuration. But instead of uploading it directly to Shotgun, you can write a simple build script, which calls the Toolkit API to identify all the dependencies. These are then each downloaded into the configuration, and you end up with a self-contained structure. This is then zipped up and uploaded to Shotgun. And when a user is running Shotgun Desktop, it simply downloads the self-contained bundle from Shotgun, and that contains everything that's needed. So the last pattern's, that's the last pattern, and it brings us to the conclusions of this talk. We've shown how Shotgun Toolkit has evolved to support today's distributed production requirements. Pearl Studio has produced a case study of their experience and their processes. We believe that these distributed pipeline patterns will become increasingly more common in the future, and Shotgun Toolkit will continue to evolve in this direction. We hope to keep pushing toward an ecosystem of workflow sharing between clients and to build a rich community around pipeline. So far, we've tackled distribution of tools. Next step would be to help distribute files. Given that Shotgun knows who is working on what and when, we are well positioned to tackle this problem. We'd also love to simplify Toolkit configuration management, as a lot of this is still done by hand. We envision a future where there is a Toolkit pipeline marketplace where you can drag and drop apps and interactively build workflows. That concludes our talk. Thanks for listening. We would also like to thank our co-authors, Satish and Rudy at Pearl Studios, who sadly couldn't be here to present with us today. And also a big thanks to all our clients who have helped us explore these patterns and help us refine our APIs and functionality. And if any of this sounds interesting, come check our SIGGRAPH 2018 hands-on cloud config developer talk on Monday. Here we'll be diving in and walking through practical step-by-step examples. Thanks for listening.